When selecting wiring for commercial air conditioning units and uninterruptible power supply, or UPS systems, the choice between copper and aluminum conductors is a common consideration. Copper remains a popular choice due to its high conductivity, durability, and resistance to corrosion. Aluminum can be used if cost is a significant concern, but it's essential to acknowledge its lower conductivity, which necessitates larger conductors compared to copper for the same amperage. A critical factor with aluminum is its propensity for oxidation. Improper termination of aluminum conductors can lead to overheating and potential electrical hazards. When it comes to UPS units, copper is often the preferred choice due to its higher conductivity and inherent reliability. While aluminum can be employed for larger UPS systems, for example, those rated at 10 kVA and above, its low cost can be attractive. However, when using aluminum for UPS systems, it's crucial to implement special precautions to prevent overheating and to guarantee proper termination techniques. For the ampacity of 4-wire, number 6 or number 8 copper type NMB cable, refer to the National Electrical Code, or NEC, Table 310.15b16. According to this table, number 6 copper type NMB cable is typically rated for 55 amps, while number 8 copper type NMB cable is rated for 40 amps. Several crucial factors deserve consideration during the selection and installation process. Firstly, always adhere to the manufacturer's specifications for the specific air conditioning unit or UPS system being installed. Secondly, ensure that the wire size and type are appropriate for the amperage and the distance of the run to minimize voltage drop and prevent overheating. Thirdly, if utilizing aluminum conductors, take extra care to ensure proper termination techniques are employed, and consider implementing additional cooling measures to mitigate the risk of overheating. Finally, contemplate the future potential for upgrades or expansion when making your choice, keeping in mind that copper is generally more flexible and allows for easier changes down the line. Many electricians tend to favor copper conductors due to their reliability and ease of use during installation. Conversely, others may opt for aluminum conductors due to their cost-effectiveness, particularly in situations where budget constraints are a primary concern. Ultimately, the decision hinges on the specific application requirements and budgetary limitations of the project. For a 40 amp feeder and air conditioning unit at a distance of 75 feet, several factors must be carefully considered to ensure a safe and code-compliant installation. Firstly, conductor material selection, whether copper or aluminum, significantly impacts the required wire size and termination methods. Secondly, ampacity requirements and the appropriate National Electrical Code, or NEC, tables for determining conductor ampacity based on insulation type and installation conditions. Thirdly, voltage drop calculations to ensure that the voltage at the air conditioning unit remains within acceptable limits under full load conditions. Finally, proper termination techniques and the use of appropriate connectors and antioxidant compounds, especially when using aluminum conductors, to prevent overheating and ensure reliable connections. For the choice between copper and aluminum conductors, copper offers higher conductivity and corrosion resistance, making it the preferred choice for many electricians. However, aluminum is a cost-effective alternative, especially for longer runs or larger conductor sizes, provided that proper installation techniques are followed. When using aluminum conductors, it is essential to use connectors and tools specifically designed for aluminum, and to apply an antioxidant compound to the conductor before making the connection to prevent oxidation and ensure a reliable electrical connection. The National Electrical Code, or NEC, provides tables for determining the ampacity of conductors based on their size, insulation type, and installation conditions. For example, Table 310.15b16 provides ampacity ratings for insulated conductors rated up to 600 volts, installed in raceways or cables, and based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. For a 40 amp feed, number 8 copper conductors with type THHN or THWN insulation would typically be sufficient, as they have an ampacity of 40 amps at 75 degrees Celsius. However, if using number 8 aluminum conductors, the ampacity is lower, typically around 30 amps, which would not be sufficient for a 40 amp load. In that case, you would need to use a larger conductor size, such as number 6 aluminum, which has an ampacity of around 40 amps. Voltage drop is an important consideration, especially for longer runs, as excessive voltage drop can cause the air conditioning unit to operate inefficiently or even fail. The National Electrical Code, or NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant for the conductor material, 12.9 ohms circular mils per foot for copper and 21.2 ohms circular mils per foot for aluminum. I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor in circular mils. For number 8 copper conductors, the circular mils is 16,510, and for number 6 copper conductors, the circular mils is 26,240. For number 8 aluminum conductors, the circular mils is 10,380, and for number 6 aluminum conductors, the circular mils is 16,640. Using this formula, we can calculate the voltage drop for different conductor sizes and materials. For example, if using number 8 copper conductors for 75-foot run with a 40 amp load, the voltage drop would be 2 times 12.9 times 40 times 75 divided by 16,510, which equals approximately 2.34 volts, or about 1.95% of a 120 volt system. This is well within the recommended limit of 3%. However, if using number 8 aluminum conductors for the same run, the voltage drop would be 2 times 21.2 times 40 times 75 divided by 10,380, which equals approximately 12.26 volts, or about 10.22% of a 120 volt system. This is significantly above the recommended limit and would likely cause problems with the air conditioning unit. In that case, you would need to use a larger conductor size, such as number 6 aluminum, to reduce the voltage drop. Proper termination techniques are essential for ensuring a safe and reliable electrical connection, especially when using aluminum conductors. Aluminum is more prone to oxidation than copper, and the oxide layer that forms on the surface of aluminum can increase resistance and cause overheating. To prevent this, it is important to use connectors and tools specifically designed for aluminum, and to apply an antioxidant compound to the conductor before making the connection. Antioxidant compounds, such as penetrox or inox, contain zinc particles that penetrate the oxide layer and create a conductive path between the conductor and the connector. It is also important to torque the connectors to the manufacturer's specifications to ensure a tight and reliable connection. Over-tightening or under-tightening the connectors can both lead to problems such as damaged conductors or loose connections. In addition to proper termination techniques, it is also important to use the appropriate type of connector for the application. For example, compression connectors are typically used for larger conductors, as they provide a more reliable connection than screw-type connectors. Screw-type connectors can loosen over time due to vibration or thermal expansion and contraction, which can lead to overheating and potential fire hazards. When installing conductors and conduit, it is important to follow the National Electrical Code, or NEC, guidelines for fill capacity. The NEC specifies the maximum number of conductors that can be installed in a conduit of a given size based on the conductor size, insulation type, and conduit type. Overfilling a conduit can make it difficult to pull the conductors, and can also reduce the ampacity of the conductors due to reduced heat dissipation. When pulling conductors, it is important to use a pulling lubricant to reduce friction and prevent damage to the conductor insulation. Pulling lubricants are available in different formulations for different types of conductors and conduit. It is also important to avoid sharp bends in the conduit, as this can make it difficult to pull the conductors and can also damage the conductor insulation. The NEC specifies the minimum bending radius for different types of conduit, and it is important to adhere to these guidelines to ensure a safe and code-compliant installation. When running conductors through walls or ceilings, it is important to protect them from physical damage. The NEC requires that conductors be protected by conduit or other approved means where they are exposed to physical damage. For example, conductors running through a stud wall should be protected by conduit or cable armor. It is also important to seal any openings around the conductors to prevent the spread of fire or smoke. Fire-stop sealants are available in different formulations for different types of penetrations, and it is important to use the appropriate sealant for the application. When installing electrical equipment, such as disconnect switches or circuit breakers, it is important to follow the manufacturer's instructions and the NEC guidelines for installation. The equipment should be properly grounded to prevent electrical shock hazards, and the wiring should be neatly organized and properly labeled. It is also important to torque all connections to the manufacturer's specifications to ensure a tight and reliable connection. Over-tightening or under-tightening the connections can both lead to problems such as damaged equipment or loose connections. When working with electricity, it is important to always follow safe work practices. Firstly, always de-energize the circuit before working on it. Secondly, use appropriate personal protective equipment such as gloves and safety glasses. Thirdly, test the circuit to ensure that it is de-energized before working on it. And finally, never work alone. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock hazards. In summary, when feeding a 40 amp feed to an air conditioning unit at a distance of 75 feet, it is important to carefully consider the conductor material, ampacity requirements, voltage drop, and termination techniques. Copper conductors are generally preferred due to their higher conductivity and corrosion resistance, but aluminum conductors can be a cost-effective alternative, provided that proper installation techniques are followed. It is important to consult the National Electrical Code, or NEC, for guidance on conductor ampacity, voltage drop calculations, and installation requirements. Proper termination techniques and the use of appropriate connectors and antioxidant compounds are essential for ensuring a safe and reliable electrical connection, especially when using aluminum conductors. Finally, always follow safe work practices when working with electricity to protect yourself and others from electrical shock hazards.